Okay, so now we're going to take another stab at this summary of key points. Now that you've been through a bunch of programming, maybe this will make more sense to you. Maybe you'll have more questions about it. So what parts of SPICE do you need to use? Well, again, it depends on what you're trying to do. Are you planning or are you doing science analysis? Are you doing science or are you doing engineering? Are you working on a flying mission or working on a mission concept? So there's no easy answer. There's nevertheless a lot of SPICE APIs out there that probably can help do many of the computations that you're interested in. And we'll try and highlight some of those here in the next few charts. So again, a summary of the major subsystems that are in SPICE. Now you're very familiar with all of these. You could probably recite this chart by heart. And then this was one of three, I think, key slides in this presentation that says if you know you have to work with an SPK file, what are your choices for getting data from that and using it? And that's what this top box is intended to show. These are the primary high-level user interfaces to SPK files. There are a lot more available, well, not a lot more, but a few more. And occasionally one of the lower level ones would be useful to you, but these are the primary ones for SPK, and similarly for the rest of the kernels. So there's no need to go through this anymore. You've heard about all of this stuff several times now. The important thing is just be aware that this chart is here to perhaps help you find the routine that you want. And again, in the inverse sense, if you got a particular subroutine and you're wondering, gee, which kernels do I need in order to support this routine? This chart is intended to help talk about that. And the important thing here again is that there's sometimes some maybes and some likely additional routine kernels that you might need that wouldn't be very obvious to begin with. And we've tried to give you a little flavor for that. One good place to get a better sense for this with regards to SPK files is to look at the backup charts in the SPK tutorial. I think we had a bunch of them that we didn't go through, and those show typical problems in trying to use SPK file. For instance, you're trying to get the position of a Mars rover relative to a deep space station, and you've got some SPK loaded, but you don't have, for instance, the SPK loaded that shows where the DSN station is relative to the center of Earth. And so you can't connect the dots because you're missing some non-obvious SPK trajectory data. So keep this chart under your pillow as well. And this was the companion to that chart for some of the other top-level routines. And you can see there really are an awful lot of L's and M's there, so it's not as straightforward as one might think it might be. Remember, your kernels must contain data for the objects of interest. Sometimes you need some intermediary objects to complete a loop, to chain data together. Make sure the kernels have the time span coverage that you need, and in doing that with especially SPK files, don't forget the difference between TDB, or ephemeris time, and UTC time. The difference being about a little over a minute right now. Make sure you've loaded all the kernels of different types that are needed. Again, we'll refer to the two previous charts. And if there are any questions about precedence, make sure you have loaded the files in the correct order. So if you're using predict and reconstructed SPK file and you want to use reconstructed most of the time and only use predict when there's no reconstructed available, well, you want to load the predict file first and then the reconstruction file, because the last loaded file takes precedence. So don't forget that precedence rule. Oops. And Boris really just went through all of this, so I don't think we need to repeat these three categories. Remember that sometimes generic kernels are also available in our archive data set or in our mission operations data sets. And again, there's lots of documentation provided in different forms that try to help you find an API that does what you want. Tutorials talks about quite a few of them, but this permuted index, which you maybe had a chance to look at, maybe not, you might find that useful. Some people like it, some people think it's not worth it at all. We decided to leave it there for those people who do like it. Try it out. And these awful, huge required reading documents, the technical references, they tend to be pretty thick. They have a lot of meat in them. People don't like to read that sort of documentation, but those are there in case you're really searching for some low-level information about a particular subsystem. As I said earlier, you can actually Google a subroutine name to see the header for that file. If you type into Google nav spice and then the name of the subroutine, that's one quick way to bring up the header for that file because it's all indexed by Google. So I think we really did that. Yes. Has been pointed out a number of times, all of the newer subroutines APIs have working examples. Something you might not expect to find in some other library. So be sure to look at the headers and look at the examples in there, and a lot of them actually you can cut and paste and see that they actually work. There's in our backup tutorials, there are 4 sample programs, one each for Fortran, C, IDL, and MATLAB. Unfortunately, we don't have it for Python. And those it's the same program in each case, done in the 4 different languages. And it's a fairly robust program, and you might find it useful to look at that, because we give all of the code, bit by bit, showing how we developed the program. And you might find that useful to look at. So I think that's pretty much it.